All right, welcome back. It is more nomenclature in this quick video. We're going to cover type 2 in this video, also ionic compounds. If you haven't seen the first one about type 1 ionic compounds, I'll try to put a little link here and you might want to go watch that. But here we're just going to kind of pick up with the assumption perhaps you watched that video and you kind of got the background here on naming and ions. So once again, a reminder, ionic compounds are going to be always a metal and a non-metal. And when we talk about type 2 ionic compounds, we will get our formation of our ions because our metal is going to transfer electrons, creating again our cation, which is positively charged, and our anion, which is negatively charged. And here, whenever a metal is involved, as we talked about in the previous little video there, it's always really the most important thing. And what makes something a type 2 metal is it typically is going to be a transition metal, are really just to the right of it under the staircase there. And the staircase is where we have our semi-metals on the periodic table. So you got like boron up here, you got your little staircase happening, you got like your transition metals here. Underneath here, you got things like lead, tin, antimony, bismuth, very bad B, bismuth, etc. So these guys that are not technically transition metals do have a variable type charge like transition metals. So they're kind of grouped in with them. The three that are not grouped in with the transition metals, which again are right here in the transition metal region, that is our zinc, our cadmium, and our silver. Remember that these guys, although they are transition metals, these are type 1 transition metals. What's the difference between type 1 and type 2? Well, type 2, which we're talking about here, has a variable positive charge. So depending on the situation, perhaps that metal may be +2, maybe +1, maybe +3. And that's different than type 1, which has a fixed positive charge. And for example, these two transition metals always going to be a +2, silver always going to be a +1. So again, those are not included in type 2. Type 2 will have a variable charge. For example, copper can be +1 in certain situations. Copper can be +2 in certain situations. Iron can be +2. Iron can be +3. So depending on the situation, it may be a different charge. So how do we go about naming these guys? Well, we do follow very similar to how we do type 1, but with type 2, we go with still the whole name of the metal. The non-metal is still going to be used. We're going to drop the last part like we've done previously with type 1. We're going to add the IDE. The additional thing that is done here with type 2 is we have a Roman numeral. And the Roman numeral actually indicates the positive charge on the metal. Now, people always sort of mess this up. They think perhaps the Roman numeral is how many metals they have. It's sometimes they think it's the total positive charge of all the metals together. It's not. So what the Roman numeral is if you took one of those positively charged cations out by itself, what the positive charge is on it. So that is the difference between type 1 and type 2. Type 2, because these metals can have more than one charge, we need to tell people when they're looking at it, hey, in this case, we're dealing with the metal with a +2 charge, or we're dealing with the metal with a +3 charge. So that's what the Roman numeral helps us decide. How do we figure out what the charge is? The good news is you will always know the charge of what it is bound to. So you'll always know the charge of what the metal is bound to, which means all you have to do is sort of back calculate and figure out what the actual charge is on that particular metal. So for example, if we had FeBr2, we would start with the identification like we did previously in type 1. That is a metal. That is a non-metal. So that automatically tells me I am dealing with an ionic compound. Once again, metal involved, most important. I'm going to look at this metal and I'm going to find it in a transition metal, pretty much dead center of the transition metal region. That automatically tells me it's a type 2. That then should tell you it could have a variable charge, and I need to figure out what the charge is. So here's one very simple way you can figure out the charge. You know from the formula you got 1 iron, which can have a variable charge. What you do know is the non-metal that's attached to it is bromine, and that is group 7 on the periodic table, which means it has a -1 charge. We do not just have 1 bromine, but we actually have 2, which means we don't have 1 anion there. We actually have 2 of them. If we add up all the negative charge for our anions, that's -1 and -1 gives us a grand total of -2. Remember that when you put anything that's positive and negative together, the overall charge needs to equal 0. In order to do that, my iron must have a +2 charge. And once you figure that out, you could roll right to naming. So whole name of the metal, which in this case would be iron, Roman numeral 2, not for how many metals we have, but for the positive charge that's on that metal. And our non-metal gets the IDE treatment. And again, that is going to be iron, Roman numeral 2, bromide. Once again, it bears repeating. No to your question of, is it a dibromide? Again, no prefixes. How do I know? Like we talked about in the previous video, I see a metal, which means I should not see a prefix. So again, if there is a metal there, you should not be using a prefix. Doesn't matter how many you have of the metal, doesn't matter how many you have of the non-metal in type 2, no prefixes anywhere when you do it. So let's take a look at a couple more here. We have CuO in this case. Once again, I look at it here. That is copper, which is a metal. That is oxygen, which is a non-metal. Once again, that's going to tell me ionic. Metal, most important one. Copper can be found in the transition metal, which tells me this is a type 2 because it can have a variable charge because of that transition metal status. That means we need to figure it out. So Cu, not sure the charge. Now I want to focus my attention to the oxygen. That I do know the charge because that is group number 6, which means it has a -2 charge. Again, when these add up, they need to equal 0. That means here my copper should have a +2 charge. This is going to give me copper Roman numeral 2, once again for the charge, and oxide. Now, if we look at something like PbO2, why don't you take a moment there and think about what you might think it would be, right? So let's take a look. So once again, that is a metal, the Pb, which is lead. Oxygen is a non-metal, so I do know it is ionic. The metals involved, and it's not a transition metal, but it is one of those ones to the right, which does have a variable charge, so that makes it a type 2. I again want to figure out what's going on. I don't know the charge on the lead. I do know my oxygen here, group 6 as we've seen, which is -2. There's actually 2 of them there. -2. That is a grand total of -4. That means my lead here is actually +4. Maybe not +2, like maybe some of you might have thought. This is going to then be lead Roman numeral 4 because of the charge. And again, it doesn't matter. I got multiple oxygens there. It's going to be oxide in this case. This is one of those examples we talked about in the previous video where sometimes people will just do this move. And again, that's going to give you the wrong answer. So as I mentioned before, just kind of moving subscripts up or moving superscripts down will work in 94% of the time, probably. But you will definitely get some wrong. This is an example where it is a very common mistake. People will end up with lead 2 oxide because of that. So again, if drawing it out helps you, sometimes it's just easier to visually see it, and it can be very helpful. Now, if I look at something like a name and I want the actual formula from it, so let's just say we had nickel for, let's do nickel for sulfide. Now, when I see this Roman numeral, I actually know it's type 2. And the nice thing about seeing that Roman numeral is I already know it's ionic, and I know the charge of it is +4, as that's what the Roman numeral basically means. Sulfide is sulfur from the periodic table, group 6. So basically, I'm putting together a +4 and a -2. And again, we need to get this guy to 4, so I need one more. And that gives me a -4 to balance out the +4. That gives me 0. Gonna make everybody happy. Now, how many of each of these do I have? Well, I got 1 nickel, so I just write 1 nickel. I got 1 and 2 of those guys, and 2 again. Subscript goes to the guy to the left there, and that would give us our proper formula in this case. Now, if I had copper, Roman numeral 1, let's do nitride. Again, when I see that Roman numeral, it tells me the copper is carrying a +1 charge. Nitride is nitrogen, group 5 on the periodic table, -3. Again, -3 and +1 means I need to get my copper really to 3 to balance it out. So I need not 1, not 2, but 1, 2, and 3 of these will give me a +3 that will balance out the -3. And now I can just write what I have: 1, 2, 3 coppers and 1 nitrogen. And that will give me my proper formulas. So you will always know the charge of whatever the transition metals bound to, or the type 2 metals bound to. You could work your way backwards to figure out what the actual charge is on the metal, and you can use the appropriate Roman numeral to fix it. One last example here before we finish up. I think let's take a look at let's do cobalt to bromide. Again, I see Roman numeral tells me it's a type 2. That is a cobalt with a +2. Again, what the Roman numeral means. Bromide is group 7 -1. Need to get to 0, +2, -1. Need one more of this guy. Gives me -2 to balance out my +2. I got 1 cobalt and 1 and 2 bromines. And there we go. So type 2 ionic compounds, metal, non-metal, ionic compound, no sharing of electrons. Metal, always the important one, going to be a transition metal, or just to the right where you have lead 10 underneath the staircase. They have a variable positive charge. So that means in this situation, you need to use a Roman numeral to tell people what the charge is on the positive ion, or the metal in this particular case. All right, that wraps up this really quick video here about type 2 nomenclature. Again, I hope it's helpful, and let me know if there's anything else you'd like to know about in terms of chemistry that I can make a short video on. Have a good one. Thanks for joining us.